This is the second year for the Smart Girls Camp, and as I said, last year was one of the greatest success stories that we've had, or I've had, as an engineering challenge week-long workshop. And the same thing was going on this year already. That was by day or 2 or 3, there were middle and high school age girls running the lab themselves. It sort of became a fab lab where we weren't up doing instruction the entire time and lecturing them and doing that, that they were using the machines as they needed to, and they were running projects themselves on the laser cutters. It happened last year, it happened this year, and it just, again, goes against that mold of like, this isn't a field for girls to get into, which is not true at all. Anybody can do this that's interested in it. So yeah, it's really fun. The Mobile Fab Lab can be used for 2 distinct goals. One is teacher professional development, and the second is project workshops or engineering challenge workshops like that was run this week, week-long camps. We can also do single-day visits. So we can do large groups of students that move through the lab, just sort of scratch the surface of CAD programming and CNC machining, but we can also have the really in-depth projects like we did this week with a smaller number of students that come back to the lab for multiple hours and learn how to really do the engineering design process, which is to troubleshoot, which is, girls are still in the room right now, troubleshooting their quadcopters even after having worked with it for 10 or 11 hours. Out of all of the different camps and project workshops and engineering challenges that we run, this is without a doubt the capstone and the most difficult one that we can run. Quadcopters are complete live control, and even though probably one of the expectations I set is I've been flying these for a year and a half, I'm really good at them. So I come in and I demonstrate for them, like, here's what a quadcopter does, and they think like, oh, he must have just done that, that's amazing. They don't realize, and I tell them I've been doing this for a year and a half, it's not that easy to do. So I think a lot of them were really good with the CAD design. They can grasp the computer component, they can get the parts installed, follow the schematics that I gave them and how to build this thing, and then when they actually fire it up, they're sort of amazed at how difficult this actually is to fly. Although there were, of course, 5 or 6 or 7 really good standout pilots who you can just tell have that natural knack for this, immediately figured it out, and they're doing really, really well. To set up an obstacle course, a simple obstacle course. I'm pragmatic with, they've only had 2 or 3 hours of a handful of flights. They're going to put some target pads on the floor, and the girls will have about 90 seconds to go out, land on the one target, go across the gym, land on the other, make a complete circuit, and come back to themselves. But it's basically just to showcase the quadcopter that they made, show everybody that they fly, and again, give these students that are standout students that really put a lot of work into this, give them an opportunity to kind of show off a little bit too. The amount of work that it took to get to that perfect veneer is not often talked about, where you order something off of Amazon or walk into Target, the amount of work and failures that went into making something great, and a product that people would want to buy, or something that people would want, that first initial failure doesn't cause frustration, doesn't cause stress, doesn't cause them want to give up. They sort of look at it like, it didn't work, let's move on to the next step. I could feel some of that frustration early in the week when the quadcopters didn't immediately work right away, but by the end of the week we're down to only 1 or 2 that were still, and they're sticking with it. And I saw a lot of the girls go through 5, 6, 7 designs. They did not give up. So I hope they could take that and not only apply it to STEM classes they may take in high school or college or beyond, but they can apply that to other areas of their life. The initial failures don't need to be the end all. Learn from it and move on.